Good morning, everyone. So, this is the next class for you people on YouTube live. So, today we are going to study about the different aspects of D and F block elements. Okay, D and F block elements. Fine. So, let us start. Just give me a minute. Yes. So, myself, Priya RK, and I am a top educator in EAMCET category for both TS and AP, and I have 4 years of experience in teaching JEE, NEET and as well as CET. And also CET ranks as well as NEET and JEE ranks has been produced under my supervision, and very good ranks. So this is my code PRKLIVE. There are 3 plans. So you can use this code in order to get 10% off on this plus subscription. That is for 12 months you have 12,375. For 6 months the price is about 10,125, and for 1 month it is 2,250 rupees. And this plan is only for the new subscribers. Okay, this is a trial price. So if you want to get any 10% off on this package, you can use the code PRK live. So here, why we need to go for plus subscription? Though we have a free classes, why we need to go for plus subscription? So here you will be having unlimited access to the content, any category, whatever you want, you can use it. Then, so, and also you'll be having live classes 24/7, and doubt clearing sessions will be there separately. Quiz will be organized at regular intervals, and also you will be having DPPs. Test series will be there based on DPPs. Also, you will be having mock test. Okay, myself also I take mock test sometimes, and in a single subscription you will be having unlimited access, right? So you can just go for this and make use of it. Good morning, Shafakat. Hi, Aman. Sachita, good morning. Sunil, good morning. Sanjana, good morning. Very good morning, everyone. Yes. So today we are going to study about coordination compounds. Okay. So I've taken a part of it of coordination compounds, and most probably in that I am taking VBT, CFT and isomerism. Okay. So basically this entire course has been dealt uh, in the app that is on the platform of Unacademy. So today we'll be having a highlight of this, what all things are more important over in this chapter. So let us go for coordination compounds. Okay, so all of you ready for the chapter? Quick revision on this. Few topics I have taken up here which I feel are important, because in the beginning it's only about the definitions that you people can easily do. Yeah. So here we are going to study about isomerism. Isomerism. What is isomerism? Isomerism is a phenomenon where compounds have the same molecular formula. Molecular formula remains the same, but the structural arrangement would be different. Structural arrangement would be quite different. And one more thing I would like to tell you people, that thank you for so much of support. So just yesterday I was scrolling down to different videos taken by different other lecturers also on YouTube session, like for 30 minutes or 35 minutes. Usually it will be there. If you can just scroll down, you can just press on the Unacademy EA. If you see on your screen, you will be getting Unacademy EA. Beside the subscription, just you have subscribed, right? Beside the bell icon, So if you just click on that, you'll be getting different people who have taken different classes, right? And how many people have watched it, or how many people have gone through the video. So what I feel like is, in last 15 days, if you compare in the last 10 or 15 days, my video has been streamed for the most views. Okay, most of them have viewed my video, and I have quite a good number of views in this. So I just suggest you people to please tell your friends to subscribe to this channel and watch the live classes and get the benefit out of it. Okay, yeah, right. So here, isomerism, as I said, it is a phenomenon where compounds will be having same molecular formula, but they'll be arrangement will be different. So based on this, we have different types of isomerism. The first one is ionization isomerism. Ionization means, as the name itself suggests, here the ions will be formed are different. Though the molecule has the same molecular formula, or though the compound has the same molecular formula, but once it is dissolved in any particular medium, the ions formed would be different. Now, what is the meaning of this? Let us see. So, if you just see this compound, cobalt, here also cobalt is present, NH3, NH3, 5 numbers, 5 numbers. Okay. So, 5 moles of NH3 are present. Then here sulfate is present, here also sulfate is present, bromine is present, here also bromine is present. Good morning, Bhagyashri. Good morning, Padmaja, Sonali, Pranjal. Very good morning. Good morning, Prathamesh. Thank you, Padmaja, for joining. Please stay tuned. Yeah. So, if you just see, in both of them, we have the same molecular formula. But what is different? Now, when I dissolve this in a particular medium, the first compound, which is actually red-violet in color, just for your information, if I dissolve it in water, how it will form the ions? Here it will form Br minus. Now, it has formed Br minus. So, ultimately on this coordination sphere, what you get is a positive charge. Okay. Let us see, when I dissolve this particular compound, what will be formed. Now, if I dissolve this particular compound in a particular solvent, then what ions will be formed? Sulfate. Definitely, it is outside the coordination sphere. So, SO4, 2 minus. Here we have 2 minus. Definitely, it will be 2 plus here, just to balance the charge. So, if you just observe, in these two, molecular formula remains the same. But the ions formed are different. Here, Br minus ion, sulfate ion, and this is one coordination sphere ion. This is also one more ion, right? So, hope you all understood what is the meaning of ionization, isomerism. Good morning, Girish. Thank you so much for joining. Good morning, Sudham, Chaitra. Good morning. Yeah. Coming to the next type of isomerism, linkage isomerism. Second type of isomerism. Now here also same molecular formula is there, but what they differ in is the linkage. So can anyone comment in the comment section what type of ligands? So you have studied, I think yesterday's class or day before yesterday's class also we have discussed this. What type of ligands would form linkage isomerism? Very simple answer. So like slight time gap is there between what I ask and when you reply. So I'll wait for you people. You can answer in the comment section. Right answer given by Prathamesh, that is ambidentate ligands. Now what is the meaning of ambidentate ligands? Ambidentate ligands are those ligands which have more than one attaching atom, okay, in its particular molecule, right? For example, if you see NCS minus or CNS minus, or you can also see ONO and NO2. So here nitrogen also have lone pair of electron, it can get attached with the metal. Even oxygen has lone pair of electron, even that can get attached with the metal. Here also nitrogen has lone pair of electron, it can get attached with the metal. Carbon has lone pair of electron, even that can get attached with the metal. So same ligand, if you see both of them, they're same, nitrogen, nitrogen, carbon, carbon, sulfur, sulfur. But the attaching atoms are different. That is the meaning of ambidentate. Okay, right. So how that can be used in isomerism, right? How that can be used in isomerism. So let us see this. So definitely, as the name itself suggests, linkage isomerism means definitely it is going to link with two different atoms. For example, here they have taken NO2. Welcome Shweta, Pritam, thank you so much for joining. Yeah. So here nitrogen is attached with the Fe. N double bond O, right? N double bond O, just a slight error here, right? So here it is getting attached with the nitrogen, but here also the same ligand is there, NO2, here also NO2, but here it is attaching with the electrons that are present on the oxygen. So that's what we call it as a linkage isomerism. Both have the same molecular formula, 1Fe, 5 chlorides, then 1 mole of NO2, 1 mole of NO2. Only the linkage differs. Here it is linked through nitrogen, here it is linked through oxygen. Okay, so that's the meaning of nothing but linkage isomerism. Next is coordination isomerism. In coordination isomerism, very shortly what I can say, there is interchange of the ligands. There is interchange of the ligands. Now what is the meaning of this? So let us see. This is one entire. Okay, this entire one is a particular coordination complex. Okay, not separate. It's a completely one coordination compound. Right? Yes. Now just see here, zinc is attached with 4 moles of ammonia with the 2 plus charge. Copper is attached with 4 moles of chloride. So just to see this, and now here. Now what has happened? There is exchange of the ligand. Now copper is here, it was with chloride. But in this example, what we have done? We have made copper to get attached with the ammonia. We have made copper to get attached with ammonia, and zinc is getting attached with the chloride. So in coordination isomerism, definitely again you can see molecular formulas remain same, but what has changed is interchange of ligands have happened. So that is the meaning of coordination isomerism. Last one, hydrate isomerism. Okay, hydrate isomerism, as the name itself suggests, hydrate means water. Hydrate means water. Yes, right. Now here, definitely again they will be having same molecular formula, but they differ in the water molecule inside and outside the coordination sphere. Inside and outside the coordination sphere. Yeah. Okay, now what is the meaning of this now? Here you can just see chromium is attached with 1, 2, 3, 4, 5, 6. 6 water molecules, and outside the bracket we have Cl3. In this example, you can see one of the Cl has come inside and one of the water has gone outside. But both of them, they have same molecular formula. Let us come back to this one. Here what has happened, 2 chlorides have come inside the coordination sphere, and 2 water molecules have gone outside the coordination sphere. But total number of water molecules, total number of chlorides, total number of chromiums remain same in all of them. 6 water molecules in all of them, 2 here, 4 inside, 1 here, 5 inside, 6 inside, 6 water molecules, 3 chlorides, 3 chlorides, 3 chlorides, 1 chromium, 1 chromium, 1 chromium. So what they differ is the number of water molecules inside the coordination sphere and outside the coordination sphere. So hope I made that clear, all of you. Understanding, everyone? You can let me know by a comment in the comment section. Okay, now one very important thing in this chapter is VBT and CFT. Okay, VBT. So VBT, all of you have learned valence bond theory. So let us just discuss the structures of certain compounds like nickel tetracarbonyl, then NiCl4 2 minus, NiCN4 2 minus, and all. Okay, fine. So these are certain silent features of VBT. Salient features. This features are already learned. Let me just revise it. So the metal provides its d orbital for bonding with the ligands, and metal, as you know, it is electron deficient in nature. Therefore ligands, as you know, they are electron rich in nature, and that's how what they do is they usually donate their electrons to the metal, and while donating, the electrons are received by the central metal in the vacant d orbital, right? In the vacant d orbital. Now what type of bond is formed? Coordinate bond is formed. What is a coordination bond? When ligand donates its metal electrons to the metal. So we usually represent coordination bond in this manner. Okay, coordination bond is represented by the from the donor to the receiver. So who is the donor here? Ligand is the donor. Who is the receiver of the electron? Metal is the receiver of the electrons, right? Okay. So during the donation, there will be formation of coordination bond. Now how these bonds are formed? What is the entire concept? Let us just see by taking certain example. So here what you need to know is the atomic numbers, okay, atomic numbers and electronic configurations. That is must here, okay. If you do not know electronic configuration and atomic numbers, it can't be done, okay. So let us just see one example. Cobalt 3 plus, okay. So cobalt is atomic number 27. 27 means it will be argon 18, 3d7, 4s2. But here it is cobalt 3 plus. Yes or no? It's cobalt 3 plus. That means we have to remove 3 electrons. 3 plus. So whenever it is plus sign, I hope you should know that it will donate 3 electrons. So cobalt 3 plus. Let me just write it here. So what it will give here? Argon 18. First 2 electrons must be removed from the 4s orbital and next 1 electron from the d orbital from here. So it will be 3d6, 4s 0. So that's what so this is actually cobalt, not cobalt 3 plus. Okay, this is what is represent is cobalt, right, and not cobalt 3 plus. So cobalt 3 plus is 3d6, 4s 0. Now if you know the coordination number, if you know the charges over it, we can just observe this particular phenomenon. So based on every type of hybridization, we have a particular structure. Like sp hybridization, we have linear. sp2 hybridization, we have trigonal planar. sp3 or even sd3, we have tetrahedral. dsp2 or sp2d, sp2d square planar, and dsp3 trigonal bipyramidal, and dsp3 or sp3d, it is nothing but octahedral. Okay, so this hybridization you must know in order to solve any particular question. So one important thing that I have mentioned here is whenever you have dsp2 or sp2d or square planar geometry, the d orbital which is used is a dx square minus y square. This you can just make a note of it, that it will be ds square minus y square. Next is dsp3. Whenever it is dsp3, the d orbital used is dz square. The d orbital used is dz square. Okay, so please make sure that you remember this. Whenever it is dsp2, it is dx square minus y square. Whenever it is dsp3, it is dz square orbital that is being used. Okay. Now, what's one very important thing? Actually, this was explained from CFT, but you should know in order to solve the problems before only, that we have something known as spectrochemical series. Now, what is a spectrochemical series? The series of ligands which have been arranged according to their strength. Means some ligands are strong ligands, some ligands are weak ligands. Now, which ligands are strong ligands and why we call them as strong ligands, or which ligands are weak ligands and why we call them as weak ligands. So this is known as spectrochemical series. Okay. So if you just see before water, all these are weak ligands. All of them are weak ligands. And after water, these all are strong ligands. These all are strong ligands. Now, what is the basicity? What is the basic nature that we are calling them as weak ligands or strong ligands, right? Welcome, MM Patil. Thank you, Ramchand. Thank you so much for joining. Welcome, Mahalakshmi. Fine. Now, if you see, whenever we have a strong ligand, we have learned that the d orbitals, okay, all the d orbitals, they actually have same amount of energy. The dxy, dyz, dxz, dx square minus y square. and dz square. These are the 5 orbitals. They all have same energy. But when ligands come there, okay, when the ligands approach the d orbitals for bonding, what happens is splitting of the orbitals takes place, right? Splitting of these orbitals takes place into two sets. Those two sets, what they are, we'll see it later. So this splitting we usually represent it by delta, okay, or small triangle, okay, delta or small triangle. So if a strong ligand is there, the splitting will be more, means the above orbitals, 2 orbitals, and the below 3 orbitals, they will be split completely very away from each other. Whereas whenever weak ligand is there, the splitting will be less, means the both the set of orbitals, they will be near to each other, right? So that's how the meaning of this strong ligand and weak ligands is there, okay? So please try to remember at least some of them, very important ones like CO, CN, then NO2, then ammonia, these are strong ligands, NCS, then these are weak ligands. Below water, before water, whatever is there, like all the halogens you can say, they're weak ligands, okay? Right. Okay. Now, whenever we have strong ligand like NH3 or Cn minus, then pairing of electron takes place. What is this now? See, whenever we have a strong ligand, definitely the splitting will be more, right? Therefore, for example, if I have any element with a D8, 8 electrons in the d orbitals, okay, D8 system we say, then how we are going to fill the electrons? So 1, 2, 3, sorry, 1, 2, 3, 4, 5, 6. Then we have 7 and 8. So this is not a problem. Okay. First you should pair up here only. Why? Because the electron doesn't have sufficient energy to jump here, because the splitting has become more. The splitting has gone up very high, right? But if we have a weak ligand, then D8 system, for example, same again, D8 system. First what I will do, 1, 2, 3, 4, 5. So first one electron in all both the orbitals, because energy level gap is very less, right? And that's how we can first fill one electron in all the d orbitals, and then 6, 7, 8. This is how it happens, okay? Now if I take any D5 system, okay, if I take any D5 system or any D4 system also fine. So in a strong ligands it would be 1, 2, 3, 4, 5. But if any weak ligand is there, if I have any weak ligand, then how the electron distribution will take place? Okay, then 1, 2, 3, 4, 5. This is the difference. Hope you got it, all of you. You can let me know by a thumbs up or something. Yes, fine. So this is the difference. Okay, that's the difference it makes whenever strong ligand or a weak ligand is present, right? Okay. So that's the meaning. Whenever we have a strong ligand, pairing occurs. Yeah. So let us just see the structures of some of the molecules. Yeah, thank you, Chaitra. So formation of a nickel tetrachloride, tetrachloronickelate. Okay, fine. So here first thing what you need to do whenever you are doing VBT of any particular molecule and finding its structure. First find the oxidation state of metal here, which is the metal nickel. X plus 4 into minus 1, chloride minus 1 is equals to minus 2. So X value is what? Minus 2, 4 into minus 1, other side it comes plus 4. So X is in plus 2 state, that is nickel is in plus 2 state. So nickel, normal nickel is 3D8 4s2, argon 18 3D8 4s2. But when it comes to nickel plus 2, then it will be argon 18 3D8, and from here 2 electrons has to be removed, 4s0, right? Okay, now nickel in plus 2 state, it is 3D8. 1, 2, 3, 4, 5, 6, 7, 8. So 1 electron you first fill, then pairing. The next we have 4s and 4p. Okay. Now how many ligands are there? 4 ligands are there. Each ligand donates how many electrons? Donates 2 electrons, right? This is when we have unidentate ligand like chloride. So Cl minus, 4 Cl minus are there, 4 into 2, total of 8 electrons from the ligand. Fine. Now if you see, chloride is a weak ligand. So I can't pair them up. We cannot pair them up. Only when strong ligand is present, we can pair them up. But when we have weak ligands, we can't pair them. Okay, we can't pair them up. So we have to leave it as it is. Then how we can fill these 8 electrons? We can fill them in these 4s and 4p orbitals. 1, 2, 3, 4, 5, 6, 7, 8. So what is the hybridization here? sp3. So S also has been joined and P also has been joined. So 4 pair of electrons from 4 Cl minus. So whenever we have sp3 hybridization, can anyone comment what will be the structure? Whenever we have sp3 hybridization, what will be the structure? Welcome Vaishnavi. Thank you so much for joining. Yeah, I'm waiting for your reply. I know there is a time lag between what I speak and how you reply. I'll wait for you people. Whenever we have sp3 hybridization, what is the structure? Let me just mention here, weak ligand, therefore no pairing. Very simple concept. Yeah, let's go back to that image where we have seen different structures. Whenever we have sp3 hybridization, we have tetrahedral structure. We have tetrahedral structure. So, okay, sp3 hybridization, we have tetrahedral structure. One more thing what you can do here is, there are presence of unpaired electrons. Whenever unpaired electrons are there, definitely it is paramagnetic in nature. Paramagnetic in nature. Whenever any one electron unpaired or two electron unpaired or 5 electrons unpaired, then definitely it is paramagnetic in nature. Okay. Okay. Then we can also find a mu value, magnetic momentum, under root n into n plus 2. N is number of unpaired electrons. Right. So here unpaired electrons are how many? 2. So under root 2 into 2 plus 2. That is under root 2 into 2 plus 2 is 4. Under root 8. Under root 8, I think it is around 2 point something. Root 8 value is how much? One of you can quickly tell me. Root 8 value 2.8 something, right? 2.8 unit is Bohr magneton. So even if you just do VBT from here, you can find many different things, right? We can even find whether it is paramagnetic, whether it is diamagnetic, what is its magnetic momentum, what is its structure, right? All these things can be done, right? Likewise, let us just compare now. So here we have taken nickel tetrachloride, right? Likewise, we have taken here nickel tetracyanide, okay? Tetracyanonickelate or tetrachloronickelate, okay? So here it is a strong ligand, Cn minus, strong ligand. And about the nickel tetrachloride, we have just seen it is a weak ligand. It's a weak ligand, right? So here pairing will take place whenever strong ligand is there. Here weak ligand is there, therefore no pairing. No pairing. Very good. Fine. Nickel, you know it is 3D8 4s2. Right? Let me just write here. Nickel, it is 3D8 4s2. Normal nickel. In both these cases, nickel are in +2 state. Okay. So nickel 2 plus means it will be 3D8 4s0. Need 3D8 4s0. Then this is 3p. Yeah. Okay. When we have strong ligand, like this entire diagram is for strong ligand. So cyanide, how many cyanides are there? 4 Cn minus. So 4 into 2, how many electrons are there? 8 electrons are there. Fine. From ligand. Okay. So strong ligand is there. So I can pair this electron. I can pair this electron and that therefore we get this orbital. sorry, I can just show you here, nickel 2 plus. I can pair this electron and we get this orbital empty. So this orbital is empty, next 3, 4 orbitals are again empty, right? So we have 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. What is the hybridization? D, 1 d orbital, 1 s orbital and 2 p orbitals are involved. So dsp2, you have to write it in this order only or else it will change. Okay, dsp2. So whenever we have dsp2 hybridization, we say it is a square planar geometry. There is no unpaired electron, therefore it is diamagnetic. And mu value will be equal to 0 because n is equals to 0. Now coming to nickel tetracarbon, tetrachloro nickelate, we have just seen it is a weak ligand, we cannot pair them up. 4 Cl are there, that means 4 into 2 electrons, that is 8 electrons. Weak ligand, we cannot pair them, so we have to fill electrons from s orbital, 1, 2, 3, 4, 5, 6, 7, 8, right? 8 electrons are there, so 8 electrons we have filled. So what will be the hybridization? sp3 hybridization, presence of 2 unpaired electrons, therefore it will be paramagnetic, and mu value will be 2 unpaired electrons. Just now we have done this, 2 into 2 plus 2, that is equals to under root 8, 2.8. Same example was there, but just to compare, like which is a weak ligand, which is a strong ligand, how it can be done, we had taken this example, right? Okay. Someone has commented, ma'am, can we crack EAMCET without learning mechanism but remembering reactions in organic? Please help me. Yes, see, mechanism you don't have to remember. What I means, if you are not able to remember, though definitely you should know the mechanism, but if you do not remember the mechanism, it is okay. But you should know certain important species that are generated while making of that particular mechanism, while that reaction is occurring. Okay, so if you do not know a particular mechanism also, it is okay, but certain species that are generated during the mechanism, for example, if you go to Friedel-Crafts reaction, in Friedel-Crafts reaction what is happening? Aluminium chloride is reacting, right? Yes or no? So there how it is reacting, what species it is forming, that you should know. You don't have to remember the actual mechanism. For if you go for higher examinations like JEE and NEET, definitely you should need to know the mechanisms. Okay, and but for CET, what I feel is if you just know some important species, not in every reaction, in certain reactions you will be having certain important species. So please try to remember them, not the entire mechanism for CET. Okay, so hope I made that clear. Yes, fine. So all of you understood today's concept? Everyone, have you understood today's concept? Okay, let me just give you people one example. I'll keep this table for you people here only, and I would like to give you one example where you can just try to solve, okay, and tell me the answer quickly in the comment section, right? All of you ready for that? You can sit with your pen and paper. I'll keep this chart for you people if in case if you don't remember which hybridization is for which structure. I'll give you one simple example of VBT. Okay, so let me give you the example of, yeah, cobalt 2 complex. Okay, cobalt 2 complex. So I can just tell you here ammonia, it is a strong ligand and it's a unidentate ligand and it doesn't have any charge. So first to calculate the oxidation state of cobalt and try to do this question. Waiting for your replies in the comment section. No, actually here I'm just taking for 30 to 35 minutes of the class for a D and F block or any other chapter. So I'm just giving a quick recap of whatever has been taught at the Unacademy platform. So if you want the complete chapter, it has been dealt by me in the Unacademy platform. Description box of this particular video, you can get a link to my Unacademy platform and my profile. So please click on that link, follow me, and you can see the chapters there which I have covered. Even I have covered in detail with most, like almost 150, more than 150 questions have been dealt on this particular chapter D and F block elements. So you can just go through the topics there, okay, even of D and F block elements. Here I'm just giving a quick recap of whatever is important from that particular chapter. Which hybridization is for which structure? Yeah, if you have finished the answer, you can just let me know. Waiting for your replies in the comment section, all of you. Yeah. So may I know MPC crackers from which place you are and what you are pursuing presently? Yeah, others can try quickly this question and let me know the answer. I'll wait for 1 more minute. Yes, everyone. Shafaqat, Aman, Sachita, Sunil, Sanjana, Pranjal, Sonali, Bhagyashri, please try this question. And many others, Mahalakshmi, Vaishnavi, Chaitra, Prathamesh, Shweta. You can try this question. Okay, fine. Let me just tell you that it is a, I don't know how many of you have done. It is SP3D2 configuration. Sorry, D2SP3 configuration. Okay, it is D2SP3 configuration because ammonia being a strong ligand, pairing of electrons takes place in cobalt, and therefore there will be 12 electrons from the ammonia, and that can be filled into 2 d orbitals, 1 s orbital and 3 p orbitals. Okay, so you can just quickly go through this. If you have D2sp3 configuration, then definitely it is octahedral structure and all the electrons will be paired up, and it is diamagnetic in nature, and mu value will be equal to 0. Okay, so all of you please prepare for your examinations. Don't take it too lightly. So I would suggest you people to quickly go through the notes which we have already learned at an academy platform, and please make use of this. An academy is providing you free of cost classes here. Please follow me on my Unacademy page, and today I'll be going live on Unacademy platform at 11:50 a.m. Okay, at 11:50 a.m. and the topic would be amines. Okay, on Unacademy. Okay, on Unacademy. Topic would be amines. So I request all of you. Okay, very good, Shafakat. You have given the right answer. Very good. Hello, Abhishek Angolkar. So today I would like to inform you people that I'll be going live on Unacademy platform at 11:50 a.m. So link of this you can find out at my WhatsApp status and also on my profile on Unacademy app. So if you don't know what is my profile, you can go to the description of this particular video. You will get the link to my Unacademy profile. So all of you can just follow me over there, and see you all again at 11:50 a.m. for the third part of amines. So have a good day and hope the class was interesting for you people, and see you all at 11:50 a.m. today itself on Unacademy with the topic amines. Okay. Thank you so much everyone. Have a good day. Bye.